What if I told you the most important machine on Earth isn't a rocket, a fighter jet, or a supercomputer? It's a machine that prints the tiny brains inside almost every modern device: smartphones, AI chips, data centers, even future quantum computers. And, well, the crazy part? Only one company on Earth can build it: ASML. Today, we're going inside the most advanced machine ever built: EUV lithography. Modern chips contain tens of billions of transistors. Each transistor acts like a microscopic switch controlling electricity. To make them, engineers must print circuits thousands of times smaller than a human hair, and that's where lithography comes in. Think of lithography like a super advanced printing press for computer chips. Instead of ink, it uses light. Instead of paper, it uses silicon wafers. But as chips became smaller, traditional light simply couldn't keep up. This is where things get insane. Engineers had to invent a completely new type of light: extreme ultraviolet light. EUV light has a wavelength of 13.5 nanometers, allowing chip makers like TSMC, Samsung Electronics, and Intel to create chips at 5 nanometers, 3 nanometers, and beyond. Without EUV, modern smartphones and AI processors simply wouldn't exist. But creating EUV light is unbelievably difficult. To generate EUV light, the machine fires a high-power laser at microscopic droplets of molten tin, 50,000 times per second. When the laser hits the tin droplet, it creates plasma hotter than the surface of the sun. That plasma releases extreme ultraviolet light. This light then becomes the ink used to print the chip's circuits. And this is just the beginning of the machine's insane complexity. Here's the crazy twist. EUV light is so energetic that it actually gets absorbed by air and glass. That means, well, normal lenses just can't be used. Instead, the machine uses these perfect mirrors built by Zeiss Group. The mirrors are so incredibly smooth that if you scaled one up to the size of Germany, the tallest bump would be less than 1 millimeter. The light reflects through a series of these mirrors, guiding it toward the wafer with atomic-level precision. Next comes the Photomask, which acts kind of like a stencil for the chip design. The EUV light shines through this mask, projecting the microscopic circuit pattern onto a silicon wafer that's coated with special chemicals called photoresist. After exposure, chemical processes reveal the circuit design. You repeat this process hundreds of times, layer by layer, and eventually you build a modern processor. And here's something most people don't realize. A single EUV machine costs around $200 million. It weighs over 180 tons and contains more than 100,000 individual parts. In fact, shipping one machine requires multiple cargo planes and trucks. Once assembled, the machine must operate inside an ultra-clean vacuum environment. Even a single dust particle could destroy an entire chip batch. These machines are the backbone of the global semiconductor industry. Every advanced chip used in AI accelerators, smartphones, and cloud servers depends on EUV technology. Companies like NVIDIA, Apple Inc., and AMD design powerful processors. But without EUV machines, those chips could never be manufactured. In many ways, EUV lithography quietly powers the entire digital world. And the future gets even crazier. Engineers are already building the next generation called High-NA EUV. These machines will push chip sizes even smaller, enabling 2 nanometer and potentially 1.4 nanometer processors. That means faster AI systems, more powerful smartphones, and computing capabilities we can barely imagine today. So, the next time you unlock your phone, launch a game, or use an AI tool, remember that behind the scenes, there's a machine firing lasers at molten metal 50,000 times per second, all to print circuits smaller than atoms. And that machine might just be the most advanced machine humanity has ever built. If you enjoyed this deep dive into the technology powering our world, hit subscribe and turn on notifications. Because on this channel, we break down the most incredible technologies shaping the future. And trust me, the next video will blow your mind.